My dear students, in my previous video, we solved all the exercise problems in the exercise 2.3, and also we have seen the geometrical representation of conjugate of a complex number. Now, in this video, we are going to see the properties of complex conjugates. Properties of complex conjugates. That is, we have to see the properties of conjugate of a complex number. There are some 10 properties are there. Using those properties, we are going to solve the problems. Properties of complex conjugates. One by one we will see. First property, Z1 and Z2 are any two complex numbers, then Z1 plus Z2, the conjugate of the addition equal to Z1 bar plus Z2 bar. This is the first property. If Z1 and Z2 are any two complex numbers, then sum of the two conjugate of the sum of the two complex numbers is conjugate of the sum. Z1 plus Z2 bar equal to Z1 bar plus Z2 bar. Similarly, second property, Z1 minus Z2 bar, conjugate of difference equal to difference of conjugate. Z1 bar minus Z2 bar. This is the second property. Third one is Z1 into Z2 bar equal to Z1 bar into Z2 bar. Product of a conjugate equal to conjugate of the product of two numbers. Fourth one, Z1 by Z2, the whole bar equal to Z1 bar by Z2 bar. Conjugate of division of two complex numbers is equal to division of conjugates. Fifth one, real part of, if Z is a complex number, fifth one I write here. If Z is a complex number x plus iy and it's Z bar, and what is Z bar? X minus iy. If Z is x plus iy and Z bar is x minus iy, what is Z plus Z bar? Sum of its number and its conjugate is imaginary parts get cancelled because plus iy minus iy on addition it becomes 0. This is, you get 2x only. On adding these two, x plus x 2x plus iy minus iy get cancelled. So from this you get Z plus Z bar by 2 equal to x. So this is the fifth property, that is the real part of Z equal to Z plus Z bar by 2. This is the fifth property. Sixth property is imaginary part of Z equal to Z minus Z bar by 2i. This is the sixth one. How the sixth one will come, we will see. See the properties. And sixth property, you know, Z is x plus iy, Z bar is x minus iy, you know. We have to subtract Z and Z bar, Z minus Z bar. On subtraction, this becomes minus. So x cancelled. And this minus becomes plus. Otherwise, x plus iy minus x minus iy. On subtraction, it will come like that. X plus iy minus x minus y plus iy. So x plus x and minus x get cancelled. There becomes 0, you get 2iy. From this, y equal to z minus z bar by this denominator 2a will come to the left hand side, it becomes to the denominator. So y is the imaginary part of z. So the imaginary part of z is z minus z bar by 2i. This is the method we derive the second property. Okay, and seventh one is z power n, the whole bar equal to z bar power n. Z power n, the conjugate of z power n is z bar power n. This is the seventh property. Next, eighth one. If a complex number and its conjugate are equal, I already told you, if z and z bar are equal, then the complex number is a real number. Then z is a real number. This is the eighth property. If a number is real, then the number and its conjugate are equal. For example, 5 is, suppose z is a real number 5, z bar is also a same 5. Therefore, the z equal to z bar implies that z is a real number. This is 8th one. 9th one, if z equal to minus z bar, then z is purely imaginary number. Then z is an imaginary number. Imaginary number. This is how we can prove. Z is, what is that? X plus iy. Z and z bar are minus z bar are equal. That means z is some pure imaginary number, you can write 4i. What is z bar? Minus 4. Because you have to conjugate of a complex number means you have to change the imaginary part, sign of the imaginary part. That is minus 4. Minus of z bar is minus of minus 4i. It's again plus 4i only. So z and z bar minus z bar are equal. Therefore, z and minus z bar are equal if z is an imaginary number. If z is an imaginary number, then z and its negative conjugate are equal. This is the ninth property. Then last property, 10th one. Z and 10th property is z double bar equal to z20. Means the conjugate of conjugate. Conjugate of conjugate is the number z itself. This, if z is a complex number x plus iy, no, you know z bar is x minus iy. Again, conjugate of z bar. Conjugate of z bar is, again you have to change the sign of the imaginary part, is again x plus iy. If z is x plus iy, its conjugate you have to change the sign of imaginary x minus iy. Again, conjugate of conjugate z bar is, again you change the sign of imaginary, it becomes x plus iy. So both are equal. Therefore, z double bar is simply z. This is the 10th property. So I listed all the 10 properties of conjugates. Now we will pass on to the exercise 2.4 and we will solve some problems in the exercise 2.4. Explain all the properties. Exercise problem 2.4. Exercise 2.4. Write the rectangular form of the following. Write into the rectangular form. First problem is write in the rectangular form. Write the following problem in the rectangular form. Rectangular form. Rectangular form means x plus iy form. Rectangular form is x plus iy form. The one problem is conjugate of 5 plus 9i plus 2 minus 4i. Conjugate of the sum. 5 plus 9i plus 2 minus. Conjugate of the sum is sum of the conjugate. First property, that is 5 plus 9i conjugate of that plus split the conjugate 2 minus 4i. Conjugate of the sum equal to sum of the conjugate. Split like this. So conjugate of 5 minus 9i is 5 plus 9i is 5 minus 9i plus 2 minus 4i. Conjugate of this is 2 plus 4i. By adding 5 plus 2 7 minus 9i plus 4i is minus 5. 9 minus 4 5. So this is the answer for the first subdivision of the first problem. This is the answer. It is second one, rectangular form. The rectangular form of the problem is this. Second one, 10 minus 5i by 6 plus 2i. 10 minus 5i by 6 plus 2. You have to convert this problem into rectangular form. For that you have to multiply the conjugate of the denominator. 10 minus 5i into 6 plus 2i. Conjugate of the denominator is 6 minus 2i by 6 minus 2i. Conjugate multiplication numerator is 10 into 6, 60 into 10 into minus 2, minus 20i. 10 into 6, 60, 10 into minus 2i, minus 28, minus 5 into 6, minus 30i. 5 6 are 30, minus into minus plus, 5 2s are 10, I square. Numerator, denominator, a plus ib into a minus ib is a square plus b square. Therefore, the numerator, what do you get in the numerator? Simplifying, we get 60. I square is minus 1 minus 10. Here plus 38 minus 28 minus 30 minus 20i minus 30i minus 28 minus 38 I square minus 1 by 36 plus 4. 6 square 36, 2 square 4. 36 plus 4, 40. This is 1 by 40 into 60 minus 10. 50 minus 20 minus 30 minus 50i. If you take the 50 common outside, you get 50 by 40 into 1 minus I. This is 5 by 4 into 1 minus I. You can simplify. This is the rectangular form of the second sum. Okay. Super. And one more sum. Third sum is there. What is the third problem? To find the rectangular form. This is a simple problem, and I hope you understand. Next, third one is di bar conjugate plus 1 by 2 minus I. 1 by 2 minus I. This is conjugate of 3i is minus 3i. Conjugate of this is minus 3i. Plus 1 by 2 minus I. To simplify this, you multiply by 2 plus I by 2 minus 2 plus I. Denominator of the conjugate. Conjugate of the denominator. This is minus 3i plus 2 plus I into 1 is 2 plus I by a plus ib into a minus ib is a square plus b is 1 square. Coefficient of I is 1. This is again minus 3i plus 2 plus I by 4 plus 1, 5. Again by taking common LCM 5, 3 5s are minus 59 plus 2 plus I. That is 1 by 5 into 2 minus 15 plus I is minus 14I. This is the problem. 1 by 5 into 2 minus 14I. If you want, you can take 2 outside. You will get 2 by 5 into 1 minus 7I. You can write also. So that this is the rectangular form. You can leave it in the step itself, or otherwise if you take common 2 in the numerator, 2 by 5 into 1 minus 7i. So this is the rectangular form of the third sum. So all the subdivisions in the first problem are over. Now we will continue in the next video. I will stop here and we will see in the next video. Thank you.